Now, it's important for us to be able to convert back and forth between the exponential form and the logarithmic form. It's essential for us to understand where all the different pieces go. So we just kind of went over this example on the previous page. B to the x power is equal to a. When I convert that to my logarithm, remember b is my base, so I'm going to say log base b of some number a is equal to x. In other words, b times itself, x times x times here is going to produce the number a. All right, let's take a look at this example. 3 to the 5th power, which you know is 3 times itself 5 times, is going to generate the number 243. Now, if I wanted to write that in logarithmic form, I would say log base 3 of the number 243 should be equal to 5. In other words, 5 is the power I raised 3 to in order to generate 243. All right, let's try this next one now. I'm going to convert back from the log form to the exponential form. So this says log base 25 of the number 5 is equal to 1/2. In other words, 25 raised to the 1/2 power is equal to 5. And that should make sense because you should remember that the 1/2 power is the same thing as the square root. So this is equivalent to the square root of 25 is equal to 5, which is a true statement. All right, our next example says 6 to the negative 1 is equal to 1/6. Now, again, that should ring true in your minds because you know that when you have a negative exponent, it's the equivalent of placing that base under 1 and raising it to that same power. And 6 to the 1 is simply 6, so 6 to the negative 1 is 1/6. So to convert this back to logarithmic form now, I'd say log my base, which is 6, my result, which is 1/6, is equal to my exponent, which is negative 1. So this again is simply read 6 to the negative 1 is equal to 1/6. All right, now let's just take the generic form here. Log base a of some number c is equal to b. If I wanted to convert that back to exponential form, I know that a is being raised to the b power, and it will generate the number c. Now this last one here says e to the negative 1 is equal to 0.37. Again, I'm going to generate this in logarithmic form. So this is log base e of 0.37 is equivalent to that exponent, which is negative 1. Now one thing I want to change here is this log base e. Log base e is actually the improper way to name that. You want to name that as the natural log. So you'd say the ln of 0.37, which is equal to negative 1. All right, in our next few examples here, it's asking us to change from logarithmic to exponential form and then solve. So let's start off. Log base 7 of 1. So what power do I raise 7 to in order to get 1? Well, I know any number raised to the 0 power will generate 1. So now let's convert this. I'm going to convert it here to my exponential form. So 7 to the 0 is equal to 1. All right, let's take a look at the next one. Log base 5 of 0.2 is equal to what power? So what power do I raise 5 to in order to get 0.2? Now, you'll remember that 0.2 in decimal form or in fraction form is actually 1/5. So let's rewrite this. Log base 5 of 1/5 is equal to what? So what power do I raise 5 to in order to get 1/5? Well, that should be negative 1. And that will be exactly the same example that we did right up here in the middle of our chart. So I know that this is going to equal negative 1. And if I want to convert that to exponential form, I'll say 5 to the negative 1 is equal to 1/5. All right, my final example here says log base 4 of 256. In other words, what power do I raise 4 to in order to get 256? So I can start that just using my hand. I know that 4 times 4 is 16. I know that 4 times 4 times 4 is 64, and I know 4 times 4 times 4 would be 256. So in other words, I'm going to raise 4 to the 4th power. So to translate that into exponential form, I'll say 4 to the 4th equals 256.